Hello friends, welcome back to NaniCodes. Today's daily Leetcode challenge question is top K frequent words. It's a medium level question. Okay, let's discuss this question briefly. Given an array of strings, words and an integer k, return the k most frequent strings. Return the answer sorted by frequency from highest to lowest. Sort the words with the same frequency by the lexicographical order. Okay, here what they are saying is we need to return k words from the given string of words. From that we need to follow two conditions. First one is we need to sort the frequency of the strings from highest to lowest, then return the k most frequent strings. If the frequency of two words are same, then we need to go for checking lexicographical order. The string which has a lower alphabetical order, we need to return them first, then the next one to be returned. Okay, these are two examples they given to understand this problem. Let's discuss this example using whiteboard. Okay, here this example given in the question. So now we analyze how many times each word in this string is repeating, in this string of array is repeating. So first one is I is repeating 2 times, and love is repeating 2 times, and Leetcode is only 1 time in the given array, and coding is also 1 time. So here we need to return k most frequent strings, and k value is here given as 2. As k equal to 2, we need to return 2 strings. Okay, let's build the logic for the given question. Here, as we discussed, first we need to initialize a hash map. So then we need to insert all the words with their frequencies into the hash map. We'll insert all the given words in a given array. We'll insert all the words in the given array, from the given array to the hash map with their frequencies. We'll insert keys and their values, keys plus values into the hash map. So now here now we declare a priority queue. We are using min heap here. So the elements with the least frequency will be top of the priority queue. So here what we are doing is we will initialize a priority queue, and we need to follow two conditions which are mentioned in this question. They are said that we need to sort them by frequency from highest to lowest, and if they are same frequency, we need to follow lexicographical order. So here what we are doing is we will initialize a priority queue, and we will compare both the elements. Let's say first element is A and second element is B. If we compare both elements frequency, if they are same, then we need to if both elements frequency A and both second element frequency B are same, if both are same, then we need to compare them, and we will return them according to the lexicographical order. And if A has higher frequency than B, then B will be at top and A will be the next element of B. Okay, now let's erase this. Okay, this is second step we need to follow, and the third step here comes is we need to check whether the element is getting out of boundary or not. That is, first we will add First we will add the two elements. First we are adding I into the priority queue. Then after that love is added to priority queue. Okay. Now the priority queue size is queue size is equal to 2. Now we are adding one more element to the priority queue. Let's say Leetcode. Here Leetcode size is Leetcode frequency is 1, and now the priority queue size is 3. PQ size is 3, but it's increasing the size of it's increasing the value of k equal to 2. Now priority queue size is greater than k value. So now here what we do is we will pop the first element from the priority queue, which is of at least frequency. So that's the reason we are entering the elements. We are entering the element from we are using min heap, so that we can store the element with frequency less at top. So now Leetcode is popped. Now we are inserting coding here. Again the same condition. Priority queue size will be now 3. As coding has least frequency, we will pop coding also. Now only love and I are the two elements present in the priority queue. Now what we do is I'll just erase this to get some space. Now only love and I are the two words present in the priority queue. The last step we need to do is we will initialize an array list. Let's name it as to return array list. And here what we do is we will pop all these elements from priority queue. We will pop all these elements from the priority queue and add to the return array list, so that we can come out with our desired solution. This is a basic idea and algorithm we need to follow to solve the question. Let's discuss and analyze the code we written. Okay, here the code what explains is first and foremost we have declared a map. Map is a hash map will eliminate duplicates, and it will be added as key value base. We all know that, and we are inserting all the elements of given array to the map with their frequency. Here we are using these one because we need to get the default value of a default value. Means it's nothing but a frequency of a frequency of the string, or we need to assign it to 0 if it's not present before. So here what we are doing is word counts dot get or default word comma 0 plus 1. That means here what it defines means it gives default value, or or if word is not present before, it will be assigned as 0. The frequency will be assigned as 0. If it is present already, then it will take its default value and it will be incremented by 1, so that we will get the frequency of given word in the string array. So here now we comes to priority queue declaration. We declared priority queue here itself, and it will be ordered according to its lexicographical order and its frequency. Here what we done is we are using min heap as a priority queue's name, and and we are initializing the frequency of both the letters to S1 count and S2 count, and we are checking whether both the frequencies are same. If both the frequencies are turned to be same, then we need to return them as lexicographical order, so that the element with less lexicographical will be first, then the element with the higher lexicographical order. If it's not the case, then we will return S1 count minus S2 count. Now here what we do is we are offering the element to the priority queue, and if the priority queue size turns out greater than k, then we will pull the element. Here poll is nothing but we are removing the element from a given array, from a given priority queue. Okay, now the element with the highest frequencies will be left in the priority queue, and we initialize, and now we initialize the array list, and up to min heap comes out to be empty. We will add the elements to we will add the return elements to the array list, and now we just need to return array list. Okay, now let's try to run the code and submit. Okay, it's good with example test cases, and now we'll try to submit the code. Okay, it's 11 milliseconds. It's far enough. Okay, thank you. Please do consider like, share and subscribe.